Have you ever looked up at a giant fluffy cloud and thought, wait a minute, why doesn't that whole thing just fall on my head? I mean, a single cloud can weigh as much as 100 elephants. That's over 1 million pounds of water floating peacefully above us. It seems like it defies gravity, but the secret isn't magic, it's physics. So, let's break it down. First, what exactly is a cloud? It's not a solid chunk of water like an ice cube. Instead, it's a massive collection of teeny tiny water droplets or ice crystals. And when I say tiny, I mean microscopic. They're so small and lightweight that even the slightest upward movement of air can keep them suspended. Think of it like dust motes dancing in a sunbeam. You can see them floating around, not because they have no weight, but because the air currents are strong enough to hold them up. The same thing is happening inside a cloud, but on a much, much grander scale. This upward moving air is called an updraft. It's created when the sun heats the ground. The warm air near the surface becomes less dense and starts to rise. As it rises, it carries these microscopic water droplets with it. So, you have a constant battle going on up there. Gravity is trying to pull the droplets down, while the updraft is pushing them up. For a long time, the updraft wins and the cloud just hangs out, drifting across the sky. But how do we get from a floating cloud to falling rain? This is where things get interesting. For rain to happen, those tiny droplets need to team up. They need to grow bigger and heavier, so heavy that gravity finally wins the battle against the updraft. This growing process is called coalescence. Picture a massive, chaotic bumper car arena. The tiny droplets are constantly bumping into each other. When they collide, they stick together, forming a slightly larger droplet. This new, bigger droplet is a little heavier, so it might start to fall slowly. As it falls, it bumps into even more droplets on its way down, growing bigger and bigger, faster and faster. It's a chain reaction. A droplet needs to grow about 1 million times its original size to become heavy enough to fall as a raindrop. Once it reaches that critical size, the updraft can no longer support it. Gravity takes over, and it begins its journey down to Earth. But why doesn't the whole cloud fall at once? Because not all the droplets grow at the same rate. The process of coalescence happens unevenly throughout the cloud. Some droplets get lucky and collide with many others quickly, while millions of others remain tiny and continue to float. So rain is essentially the successful droplets that have won the growth race and are heavy enough to escape the cloud's updraft. The rest of the cloud stays up there, waiting for its turn. That's why rain can be a light drizzle, with just a few droplets making it down, or a heavy downpour, where a huge number of droplets have grown large enough all at once. And here's another cool fact. Sometimes what starts as a raindrop high up in a cold cloud is actually a snowflake. As it falls through warmer layers of air, it melts and turns into a raindrop before it ever reaches us. So the next time you see a dark rain cloud, you'll know it's not a solid object about to drop. It's a dynamic, turbulent place where 1 billion tiny battles between gravity and air currents are taking place. And rain is just the visible result of gravity finally winning, one drop at a time. It's a beautiful, gradual process that keeps our world watered, and thankfully keeps us from being flattened by a 1 million-pound water bomb. Thanks for watching. If you enjoyed this little dive into cloud physics, don't forget to hit that like button and subscribe for more curious questions answered. See you in the next video.